Hi, my name is Wes Ray, and I'm an applications engineer at Texas Instruments in the Consumer and Computing Interface Group. As digital content is getting richer in the form of larger files and the desire to store more files on portable consumer devices, USB 2.0 has become the bottleneck in many of the end-user sync-and-go experiences. USB 3.0, SuperSpeed USB, was developed to address this problem. USB 3 also reduces active and idle power consumption with improved power management features. SuperSpeed USB uses existing USB software infrastructure by keeping the existing software interfaces and software drivers intact. SuperSpeed USB retains backward compatibility with USB 2-based products by using the same form factor Type A connector and cables. Existing USB 2 devices will work with new USB 3 hosts, and new USB 3 devices will work with legacy USB 2 hosts. Typical applications for SuperSpeed USB include surveillance cameras, multimedia handsets, smartphones, digital still cameras, portable media players, video and wireless IP phones, personal navigation devices, and audio docks. Today, I would like to introduce the world's first discrete USB 3 SuperSpeed transceiver, which will help bring SuperSpeed USB to these devices, the TUSB 1310. The TUSB 1310 is a single-port, 5 gigabit per second USB 3 physical layer transceiver, operating off of a single reference clock provided by either a crystal or an external reference clock. The reference frequencies are selectable from 20 to 40 megahertz. The use of a single reference clock allows the TUSB 1310 to provide a cost-effective USB 3 solution with few external components and a low implementation cost. With a receiver sensitivity of less than 50 millivolts peak-to-peak, it performs twice as well as what is required by the USB 3.0 specification, enabling easier board layout and the use of longer cable links by the consumer. The USB 3 controller interfaces to the TUSB 1310 via a pipe interface for SuperSpeed and a ULPI interface for USB 2. Both are industry standard specifications. I will now show a quick demo of the TUSB 1310 connected to an FPGA configured as a SATA bridge. When we connect the SATA bridge to the USB 3 enabled PC host, you can see that it enumerates and shows up as a hard drive using the native Windows drivers. This is one of the key features of SuperSpeed USB. All existing software still works. This host PC also has TI SpeedBoost filter driver installed, which sits on top of the Windows Mass Storage class driver. This SpeedBoost driver enhances the transfer buffer size on the host PC, allowing an approximate 30% throughput increase over the default Windows Mass Storage class driver. If you run Crystal DiskMark on the drive, you can see that the throughput is 212 megabytes per second for reads and 151 megabytes per second for writes. If you run the same test on the same device with the legacy USB 2 port, you can see that the throughput is only 39 megabytes per second for reads and 26 megabytes per second for writes. To demonstrate, we will copy a 1 gigabyte file using identical equipment, one with a SuperSpeed USB 3 connection and the other with a high-speed USB 2 connection. As you can see, SuperSpeed USB provides the bandwidth needed for today's fast sync-and-go applications, as well as headroom for the next 5 years or longer. For more information, please visit ti.com/SuperSpeedUSB. Thanks.